as Will mentioned, I teach at NYU and MIT, and actually also at the Lower East Side Girls Club in Manhattan, which is part of the Mozilla Hive. And I've learned a lot from all of these teaching experiences, and I'm going to kind of share the production pipeline that I find to be very useful, and then also some of the lessons learned from my students as well, and this whole intersection of the quantified self and the smart city. And so I'll talk about those areas individually and those areas together. Does anybody here work in either of those domains? You can interpret that broadly. Great, thanks. Let's see, so the sort of the outline for today is I'll talk a little bit about quantified self and the notion of what it is, how to, some tips for accessing data, and then beyond that, tips for collecting data, so sort of building DIY sensor systems, sort of from the citizen science perspective. And then I'll talk a little bit about smart cities and what that means to me, because both the terms quantified self and smart cities can be interpreted very broadly. So I'll sort of give you my own definition of that. And then also tips and tools on the kinds of types with some examples from the classes that I teach. And then actually I'll break for Q&A, and if there's time, then I'll go into like a deeper case study with my project that Will mentioned, which is called MindWriter. Okay, and please feel free while I'm going through all these sort of tips and tools to ask a question at any point. Okay, we don't have to wait until the Q&A, since this is sort of a cooking, this is a cooking track talk, so yeah, let's have it be interactive. Okay, great. So I kind of think of, when we think of quantified self, a lot of times we think of commercial devices that we use for fitness, right? Although that's starting to change in terms of what kind of wearables are out there, what kind of ways we can track ourselves are out there with our phones, etc. I really liked a definition that one of my students this past spring in a class that I teach called the Quantified Self in the Smart City kind of talked about with Quantified Self 2.0. So the idea that you're not only tracking your own data or your friend's data, but that there is this sort of growing body of data, personal data, but also sort of biometric data as well, that is at the scale of the city. And so that's really the area in which I and a lot of people that I work with play with. But sort of that notion of quantified self 1.0 is looking at your data over time. Kind of quantified self 2.0 is looking at many people's data over time, or many people's data over space. And so some of what we do in class is access open data sets, sometimes closed data sets as well. And so particularly since we're in New York, that's a very a great city to find a lot of data. And so one thing that I find to be incredibly important is to go through that process of doing lit reviews, sort of best practice, finding the best practices around the topic that you want to research. So, for instance, my topic is the mental experiences of cyclists, while they're riding up and down the main streets of my city. So, I've come to realize that sort of doing lit review, seems kind of like a no-brainer, but it's not. So that's a big part of the process, sort of contextualizing the work in terms of the prior art and what exists already. And then I find a really important part of sort of building your project is developing constraints. So, if you're searching for open data, so this is a screenshot from NASA's data repository, Echo Reverb. And there are a lot of, even though it's sort of cut off at the edges, you can see that there are a lot of ways that you can constrain your search. So you can do a spatial search, you can do a temporal search, you can search by satellite, you can search by the level of the data that you acquire. And some of my students find that using actually NASA data has been really useful in terms of bringing multispectral data into sort of the realm of quantified self. And I'll talk a little bit more about that later. And then in a lot of cases, for instance, there in New York with NYC Open Data, but I know with other cities as well, there's this whole notion of acquiring data through queries. So if you know SQL, that's really helpful. With NYC SODA data, with NYC Open Data, there's a query language called SODA, which you might be familiar with if you've acquired city data or other kinds of municipal data sets. That's a little bit more on that. And then in some cases, not that often with the kind of projects that I do or the kind of students who are drawn to my class. And those students tend to be urban science, urban planning, and creative and design technologists, as well as journalists in many cases, the journalists who are interested in the whole sort of field of sensor and data journalism. Most of the students who I work with tend to use open data sets or collect their own data, but in some cases there's also an interest in scraping data that does not have a public API. And so that's an area that is sort of in this pipeline as well. A lot of what I spend time on is making those sort of small sensor systems, prototyping sensor systems. That's really more the domain of collecting data. So I kind of think of it as building the instrument and deploying the instrument. This is a Lego microscope, by the way, that's being built. Though in terms of building an instrument, researchers from a lot of different fields have a different idea of what building an instrument is. So in the case of my practice, it's often prototyping a sensor instrument. But in other cases, it can be putting together a survey, or it can be putting together a reporting system that people will then report information through. These are some of the most commonly used sensors in the classes that I teach, and they include biometric and environmental sensors. So for instance, a lot of the sensors in the middle that have screens on them right here, those are different kinds of gas sensors. For instance, carbon dioxide, methane, etc. We also have optical dust sensors that we use, vibration and wind, pulse, brain in some cases, skin conductance, that kind of thing. And a lot of my students, well, I'll get to that next actually. So in terms of building, can you still hear me? Okay, great. In terms of building a sensor system, these are the components that we sort of, these are the choices that you have to make. Like these are the components that, the component categories for building a kind of DIY sensor system. That includes the sensor itself. It includes a module to process the signal from the sensor. In many cases, that's an Arduino or a Raspberry Pi. That includes a way to power the system, a way to transmit the data, either through a cable or through wireless, a way to process the data on the fly in some cases, but sometimes that data is sent to a central sort of processing center. And then in many cases, there's some kind of like simple system status output. So for instance, on this microphone, I have this little green light here, and we often build like some kind of, quick status indicator. And then we go through several iterations, not just of making sure that the instrument works, but making sure that it's usable for the audience that we want to deploy it with. And so what I have circled in green are all the sort of parts that you have to test for usability. And so we spend time doing, in our classes, there's some time for user testing. We also spend a lot of time on persona design. So if any of you are familiar with that, sort of, just thinking about who is the best user for this, and let's actually sketch out a story for that, and sketch out, the process of the person using this instrument throughout the day. So, for instance, a cyclist, or someone walking to work, or someone who just got home, that kind of thing. What are the questions that they're trying to answer with this instrument? So now I'm going to go through some examples of each of the nodes in this chart. and talk about sort of the open source options and the less open source options. And I think a lot of us in our practices use a combination of open source and free and closed source, and we try to use open source when we can. But in many cases in the world of hardware, that's not so much an option, although that is changing. So for those of you who tinker with hardware, some of you have some experience with Arduino or Raspberry Pi. So those are the two sort of most popular processing units in the sensor systems that we build. I personally really like Arduino, one, because it's fully open source, but also two, because you can really it's really just plug and play in terms of connecting a sensor and getting that system up and running. Where Arduino is weak is processing signal data on the fly and analyzing, particularly analyzing it on the fly. So for students who want to have a more robust kind of analysis on the fly, for instance, I have a set of students who are deploying instruments on vehicles to test for road bumpiness, and that data is submitted to the Department of Transportation. They need something more like the Raspberry Pi that can do that kind of analysis on board without being sent somewhere else. And then as far as transmission units are concerned, in many cases you have Bluetooth. That's what I work with the most. And sometimes you have Wi-Fi, Zigbee, that kind of thing. But you kind of have to figure out, how far are you transmitting, and what is the sensor that makes the most sense for that. I do a lot of accessory type systems where I transmit the data off the Arduino to a phone. And so in many cases that phone acts as the storage unit. Here we have a phone, but then we also have a GSM radio to the left that will send a text message, or an SD card to the GSM is to the right and the SD card is to the left. So it's kind of thinking about where will your data be stored. And then also, since if you're developing sort of accessory, then the phone is also your geolocation unit. But if you're not doing that, then you also need to implement some kind of geolocation component, usually GPS. So this is an example of me sort of filling out this for a system that I would build. And so that is a combination of simplified brain sensors with a simple battery, a Bluetooth, an Arduino, a light to indicate status, and then all that information that's collected on the Arduino is transmitted to the phone. So as you can see, it's sort of a mix of open and closed. And as I mentioned, I really think that it's important to sort of think about collecting sensor data and sort of quantified self existing in tandem with other ways of collecting data. So for instance, collecting qualified data through surveys, through interviews, through reporting where there's not necessarily a moderator. And then, sort of that helps you to prepare for deploying the instrument. So this is the LEGO microscope in use. And there are a lot of sort of basic components that I ask my students to think about when they start to deploy their instrument. So one is how long will the instrument exist? Will there need to be sort of a durability or a wearability factor to it? 2, where will it be deployed? 3, who, of course. Storage, will that data need to exist on the instrument or sort of fly away into the cloud? And then processing, will the data need to be processed on the instrument or fly away into the cloud? This is an image of a military system for monitoring vital signs of soldiers. And I just thought that was very interesting in that processing is sort of taking place everywhere, because this is a very life and death situation. There's pretty heavy duty processing on the individual, but then there's also processing on the tank, on the car, a mobile command center, et cetera, et cetera. Okay, so that's kind of the overview of some quantified self type tools, and going forward into smart cities and how can you make this data mean something in terms of urban studies, urban analysis, thinking about your town, your space. As I mentioned, I kind of think of quantified self 2.0 as many people in time and space, and in a way, the smart cities really is an emphasis on space, seeing how, for instance, your stress level may correlate to areas where there are bridges and tunnels in your city, things like that. And so a lot of sort of this process begins with visualization. You have a big bunch of data, you've geolocated, or you've located it in some way. Now you need to sort of look at it. And there are a number of visualization types that are pretty common in the practice that I've been observing. These are some of the types that you'll find on visualizing.org. And I find that some are more useful than others. For instance, maps are very useful. I also think that it's helpful to think about not just 2D, but also 3D visualizations. Here's some other, here's another image of type. So in terms of two-dimensional visualizations, you usually think of sort of geographical maps. For instance, choropleth maps that show distribution of a certain phenomenon over space. A lot of what we do in our practice is dot distribution. For instance, you're wearing a sensor or you have a sensor on your vehicle that's moving in space that's collecting data once every second or every minute. So then you have a bunch of dots. And so from there you sort of map those dots out. And I'll talk a little bit more about that later. We don't use this so much, proportional symbols, but it can be really effective if you want sort of a fun way to indicate some kind of phenomenon that's understandable very quickly. For instance, I could see this being used for, like this is an example that's not quantified self so much, but maybe if you were quantifying a cow, you can use this for instance, and put a methane sensor on your cow. You could use this same kind of visualization for a quantified cow project. So right now, one of my goals in future sort of areas, or future sort of studies of quantified self in smart cities is to explore more of a three-dimensional realm. This is, and I have a background as a scientific visualizer, so that's kind of part of my agenda. This is a visualization of how water moves in the brain, and so a lot of what's available to people working in this domain are CAD computer-aided design software. So, for instance, Rhino, or which is open source, or it's free. SolidWorks, you also have Circuit Design, CAD, and what I'm really interested in is sort of exploring more spatial, geospatial, actual multi-dimensional data in multi-dimensions on an XYZ plane. And so that's not something that we've explored too much, but I think it's worth mentioning just in terms of thinking how to effectively use and visualize and convey this kind of data. Okay, so now it's time for some tools and examples in terms of visualization. So these are some of the visualization categories that I sort of go through in the process of visualizing any kind of data, particularly data that I've collected myself, or that I know from a collection that I know. And then here are highlighted in turquoise are the open source and maybe more open source, less, I didn't really highlight the free tools. And one thing that I think is notable, and for any of you who have experience with using sort of building hardware, either from the electrical engineering domain or the mechanical engineering domain. So there doesn't seem to be as much open source in terms of what tools are available, what CAD tools are available to people working with hardware. And so I'm kind of curious to know what you think about that. I'm hoping that that's something that will change. This is an example of a very timeline-based project. Basically, this group of students was working to sort of quantify the sentiment of a bar. And so you can kind of see they were experimenting with the use of emoji. And because this is a stationary project, they're looking at one location with the intention of expanding this project to other indoor locations. This is much more timeline-based. I think that they, if I recall correctly, they used a number of JavaScript libraries, mainly D3. So this is what I was talking about in terms of dot distribution being a very common way that we visualize the sort of quantifying self-data. So on the left is a project that used brain sensors on subway riders, and sort of looking at the most unpopular. So in New York, there's an organization called Strap Hangers, and they rate the different subway lines for most rider-friendly and least rider-friendly. So this group looked at the most rider-friendly and the least rider-friendly lines using EEG, and you can see where. And then they annotated, so this was one of the least rider-friendly lines, and then they annotated things that they were observing or happening in conjunction with the mental experience. So the red indicates levels of high attention. On the right is a pulse map. Basically, the instrument was tracking pulse. And then three students were walking around Brooklyn and Manhattan and sort of looking for patterns between individual pulse and environmental change. And one of the things that they found is that, while pulse is an indicator of many kinds of things, it can be an indicator of exertion, it can be an indicator of stress. One thing that did seem to be consistent is that when there was a very sudden change in sound in the environment, say you heard construction start, or the room suddenly got quiet, there was a change in pulse, and so that was sort of like their working observation that they'd like to explore more. And then finally, the lower right is a map. All of these color palettes are very similar, but they're all looking at different things. So the last map is a map of sort of the quantified car experience. A bumpiness meter was attached to a car, and with the intention of making a map of potholes of New York, sort of a real-time map of potholes, and sort of a map that can indicate to DOT and other agencies what the priorities are in street repair. This is a visualization from a group of students who was working with spectral cameras, and what they were looking at was levels of blue light in a room, and as well as levels of incandescent light, so warm light, more wide spectral light in a room. And so what they were doing was looking at that with keeping in mind some studies that they had read, that blue light or excessive exposure to blue light can be associated with depression, and that, but at the same time, blue light is more efficient. So what they're showing on the left is sort of a depression level for the room, as well as an efficiency level for that room, all based on sort of a color spectrum. I'll move on from there. So I actually did want to talk a little bit, if there's time, about the tools that are used to make some of these things. If there's interest in sort of breaking down the tools. Yes? Ish. Okay, cool. Okay, so So all of these, it's interesting because the urban studies students that I work with, the package Tableau is very popular, which is not open source at all. And I think that's very interesting. All of these visualizations are made in Tableau, but at the same time they could be made with open source software just as easily. So I'd love to get your opinion on that. Okay, great. Thank you.